For this week's lab, we focused on the topic of magnetism. Our task was to measure the force between two magnets as a function of the separation between their centre of mass. We were then asked to plot this and find the mathematical relationship between force and separation. To begin with, my group brainstormed possible experiments we could conduct that would allow us to measure this. We also threw around some of the different equations related to the topic that we knew and could possibly help us in our future calculations. Through this, we came back to our trusty formula that the gravitational force equals mass times the acceleration due to gravity. Alongside this, we also used the knowledge that opposite poles attract and that the same poles repel. We realized we could use this information to measure the repel force exerted between two of the same poles of the bar magnets, as the gravitational force must equal the repel force in order to allow the magnet to remain floating in the air. With our experiment in mind, we went and collected the necessary equipment for the experiment, including the bar magnets, 10 metal balls, a retort stand, a plastic tube, and a ruler. We set up the experiment as can be seen, placing one half of the bar magnet at the bottom of the plastic tube, aligned with the ruler. To begin with, we just measured the distance and separation between the centre of mass of the magnets, ensuring the bar magnets were rotated so that the same poles were facing each other in order to avoid them attracting rather than repelling. We then added one of the ball weights on top of the magnet, measuring how the distance between their centre of masses changed. We repeated this several times. However, we became quite confused as it seemed as if the distance between the centre of masses wasn't changing. We soon realized that this was because we were measuring from the centre mass of the magnet also plus the metal balls, meaning each time we added more of the balls, both the centre of mass would move up and the distance of separation would decrease, meaning there was no overall change. As a result, we began recording results again, this time correctly measuring just from the centre of mass of the magnets and not the entire system. Once we started doing this, the results came as expected, with the distance of separation between the magnets decreasing as the mass of the top magnet plus the metal balls increased. Using these results, we calculated the gravitational force that would have occurred at each of the different masses. From this, we used Excel to plot a graph of distance versus force. A linear fit line was then created, deriving the mathematical equation y equals negative 316.46x plus 2122.2. Johnny explained why you could obtain an equation for a straight line from the force and distance between the magnets, explaining how the magnitude of the magnetic force is determined by the changing amount of separation, r, and some constant. The log rules were used to derive this relation that the magnetic force is related to the equation of a straight line. Uncertainties that had to be taken into account for this experiment were to do with deciding where the centre of mass of the magnets was. In obtaining our results, we measured from where we thought looked like the middle of the magnet to the other magnet centre. However, a better way of doing this would have been measuring the total distance from the bottom of one magnet to the top of the other, and then subtracting the length of one magnet, which would be the equivalent of 2 half-length of the magnets. Due to this, a measurement in accuracy uncertainty of plus or minus 0.1 centimeters was considered. Although this would have affected all the different results obtained, the general trend of the graph would have remained the same. In conclusion, we used this week's lab to find the mathematical relationship between the magnetic force of magnets and their amount of separation, using the knowledge that the same poles of a magnet repel, and use the equation for the gravitational force. Overall, it was a fairly successful experiment.